What I notice is that this thing is not fitting to my board, so I'm going to readjust. Sorry. One moment. Okay, so today in Chapter 9, we're going to talk about significance tests. And a significance test is a formal procedure for comparing your observed data with some kind of claim. And the claim is always made with respect to your population. So you'll notice down below, you're making your claim about a parameter. The parameter that we use is P for the proportion, probability, area under the curve, or mu, which would be the means that we've talked about. So we've talked about P's and mu's for our populations. For example, a basketball player makes 80% of all of her free throw shots. That would be a P equal to 0.8. Notice that they use P, not P hat. The mean ACT composite score is 22.9 for Hopkins High School. That's a mu equal to 22.9. So P's and mu's. When you're doing a significance test, you state actually two different hypotheses. The first one is called your null hypothesis. That would be what you would consider the status quo, what we actually believe to be going on, or what's claimed. And then the other one is your alternative hypothesis, and that's what we suspect might be true based on evidence we found in a sample. And so they talk about this null hypothesis being what they call H0, and the alternative is HA. And you'll see that more when we actually get into the writing of these significance tests.
Good morning. This is
Okay, so when you talk about your null hypothesis or your alternative hypothesis, you're in the state part. That will be the first part of your hypothesis testing. And when we do these hypothesis tests, you can have something called a one-sided or a two-sided hypothesis claim. So one-sided is one of the most common. That's where you have something that's greater than or less than, and that's when you shade either to the right on the distribution or to the left. And then the second kind is a two-sided. That's where you have two tails, and they'll make a claim. You'll say, oh, it's not this. And that's when it's two-sided, so both tails are shaded. Each problem is something that we're going to be doing called a significance test. We'll say the null hypothesis and the alternative, and you have to define the parameter. So after you write down HO is whatever, and HA is whatever, you'll define the whatever. So if you're talking about some kind of proportion, you'll say that P is equal to what? And if you're talking about some kind of mean, you'll say mu is equal to what? And you'll put it in the context of the problem. For example, number one, a study on teenagers and their behavior revealed that 72% of all of our teens say that they seldom or never argue with their friends. Yvonne wonders whether this national result would be true in her large high school. She surveys a random sample of 150 at her school. So if we wanted to state our null hypothesis, we would say that our null hypothesis, which we call H0, is that the proportion of students is equal to 72, or 0.72. The alternative to that, if we're wondering whether or not this is true and they don't say more or less than, is that our alternative hypothesis is that the proportion is not equal to 0.72. So what you see in red are the mathematical statements, and then what we're going to do in blue is we're going to define what our P is. So then off to the side here, we will say that P is equal to the proportion of teens in Yvonne's school who rarely, let's say rarely, seldom or never argue, seldom or never argue with their friends. So the red is the math part, and the blue is the context part of what you're trying to say. Okay, so in our second example, what you'll notice is they don't offer a percentage or a proportion, so that's a clue that you'll be working with means instead of P. And so in our null hypothesis, we probably would say something like, our null hypothesis is that our mean is equal to 12, the average amount of hemoglobin. And then our alternative was that the mean are at risk of anemia, and so that's less than the 12. So I would say that my mean is less than 12, because that's when you're at risk for anemia. And then you would state, of course, that your mean is the, or the mu is the mean amount of hemoglobin in grams of Jordanian children, right? Jordanian children. So the null hypothesis is saying, hey, this is what they're saying. It's 12 grams, and we suspect that it might not be for these children, so we say less than, because that's when you get anemia. Okay, and for the record, whenever you do a null hypothesis, the null is always an equals. The alternative will always be a not equal, less than, or greater than, one of those three. So the null is always equals. Oh, I hit that. Okay, so on this page, it's mostly just reading. So here we talk about how do you interpret p-values when you actually get them. So what we're going to do is, in the part where we do, there's going to be some math, and we're going to calculate some stuff. So the null hypothesis states that we are seeking evidence against the status quo. And the p-value is your probability measuring your strength of evidence. And when you look at this, the statistic, like your sample p or your sample mean x bar, would take a value of extreme or more extreme than the one that you actually observe. And oftentimes they are going to call this significance level alpha. So you're going to compare your p-value to this alpha significance level. And in statistics, the oftentimes used alpha that they want you to look at is 0.05 or 5%. So if you find something when you take your sample that's 5% or less, you're like, whoa, this is not very common. And therefore we have evidence to reject what they say is status quo, or the null hypothesis. So that's what the p-value is talking about. And you can read down below what's going on with there. Now the weird thing in statistics, at least I find it's weird, is they have one of two phrases that they use when they talk about these significance levels, the alpha being 5% or the alpha being 1%, 3%, whatever they choose. If they don't ever tell you what the alpha is, you are going to assume and say that you assume that it's 5% or 0.05, and then compare your p-value to that. But the two phrases they use are either you reject what the status quo was, which was your null hypothesis, or you fail to reject it. They don't say you accept your alternative and you accept the null. They say you either reject it or you fail to reject it. And I find that kind of strange. Okay? So it's always about failing. The null hypothesis failed and that's why you're rejecting it, or you're failing to reject it because you didn't have enough evidence to prove otherwise. There is no rule about this p-value, and so as I said before, if you're looking and you don't know and they don't tell you, you're always going to say, hey, the significance level is 5% or 0.05 for alpha. So if they don't tell you, that's what goes on. When you do your test, if you go through all the math and you see that your alpha was 0.05 and your p-value was 0.03214, which is less than that, that's when you reject the null hypothesis. So if your p-value is less than alpha, you reject. If your p-value is not less, then you fail to reject it. If your p-value is less than alpha, you reject. And if it's not, you fail to reject. So I look at these questions here, and they give me some information. So in our previous example, when Yvonne was talking about the students who argue with their friends, 96 students in our sample said they rarely or never argue. The significance test says that the p-value is 0.0291. Let's interpret this in the context of the problem. So this is saying that based on our evidence, the proportion of students at Yvonne's school who seldom or never argue with friends. Sorry, I should say if the student or the proportion of students at Yvonne's school who seldom or never argue with friends was 0.72, there is a 2.91% chance that the survey of 96 students (96) said yes, sorry. So sorry, I have to amend this. This should have been 150 because that was what the sample said, thank you. 150 students there is a 2% chance that the survey of 100 students would yield a 0.72 result. So as you do your survey, you see that you get a P of 0.0291, and since they don't tell us alpha, we assume it's 0.05. This tells us that the likelihood when we take our sample of us finding 0.72 is 2.91%. Since that's less than the alpha of 0.05, which wasn't stated, we assume that the claim is false, and therefore we would reject their claim that 72% of the students seldom or never argue. Put it in words. So we just got done talking about part B, but I'll put it in words now. So the answer is yes, it does. Since our p-value of 0.0291 is less than 0.05 for alpha, we reject the null hypothesis H0 and conclude that the proportion of students at Yvonne's school who say they seldom or never argue with friends is not 0.72. So this is what we were talking about before. Our p-value was less than the alpha. They didn't tell us the alpha, but we know that if they don't tell us, we're going to assume it's 0.05. So this is p, and this is alpha. And when p is less than alpha, that's when we do this.
Isn't it
P. So in the second part here, now go back and if you looked at example number 2 when they were talking about Georgianian children and the hemoglobin, it says For the study, the sample mean was 11.3, and the